Let's see how we're doing with solving systems. We've got 1, 2, 3, 4, 5, 6, 7 competent people. We'll start with Ania, Zabari, Maria, Sebastian, Anissa. Okay? So you two agree. 3 people who agree. Got 4 people who all agree on the same answer. So far, every single person I've called on confirms that it is 250 hours. I also walked around and I did notice quite a few people who had 250. So, just to make sure that everyone is kind of experiencing the same thing, let's get the system that you figured out. Just give me one of the equations, just one of them. Come on. Okay, what was it before you converted it into that? Very good. X plus y equals 400. What was the second equation that, with that, formed a system? Here's a guy.
8x plus 12y equals
8x plus 12y equals 3,800. That was not the only way you could have set it up, but that was pretty much what I was looking for. You could actually switch the x's and the y's. It doesn't really matter. But you have to make sure that if you do switch them, that you know which one is which. In other words, I have made x cleanups and y painting. If you want to switch it around, that's fine. But then at the end, you have to be able to know which number is which job. Okay? But I think most of us did set up like this. And when you solve it, of course, you get 250 hours. I'm also very proud of this group who figured out that the answer was 250 hours. The answer was not 250, 150. There were a number of people who wrote that down, but then you guys did understand that the question said, how many hours did you spend doing cleanups? And so what that meant was just this first number. And so that was important to understand. You have to answer the question. Any comments or questions on today's warm-up? Okay, so I can take a look at your work and see where you went wrong. Okay? Any other comments or questions? All right, let's put today's warm-up to the side. Today you're going to learn the third and final method for solving systems. But I want to go back to where we started. So I want to look at something different. So I'd like to look here for a moment. So this is a different piece of software. It's a graphing software. And I actually have 6 equations listed right up here that you can see, but I only have 2 of them checked. So these 2 are forming a system. And here you see the graph of the system, and they cross right here. What is that location called? Where they cross. Brandon? Well, this grid actually has little lines and the darker ones, so I would call these darker ones the lattice points. But yeah, these are all lattice points, but I'm talking about what's this specific location called. Brian? Yeah, it's called the solution. Where they cross is the solution to the system. That's what you learned 2 lessons ago. That's where we started. And so we initially learned a method called graph and check, where we graphed the green line, graphed the blue line, find this point, and then we checked it by plugging it back in. Then last time, I introduced the idea of actually finding this point without drawing the graph. And that's what you did during the warm-up today, was you were able to find the solution without drawing the graph, using a method called substitution. That was very helpful and somewhat powerful, because you should have learned also that when you do the graphs, there's a lot of inaccuracies and it's hard to find the solution. Today you're going to learn another method to find the solution without having to draw the graph. And today's method is called linear combinations, or it's called elimination. They mean the same thing. I usually call it elimination. So here is the process. The first thing we need to do is have the equation set up. What is this form of an equation called? Alyssa? Very good. So reaching back to something from chapter 5, this is called standard form. And what we really want is we want the terms to line up. So we want the x's on top of the x's, the y's on top of the y's, and the constants on top of the constants. And having them both in standard form will accomplish that goal. Then we're going to do something new. We're going to change the equations. You learned how to do this in chapter 5. With standard form, you're allowed to multiply the entire equation by a number to change it. You are going to multiply maybe none of them, or one, or both equations by some number from your brain. And what we want to achieve is that one of the variables are opposites. So you're not going to understand what I'm talking about until I show you. But this is here as a fallback. Yeah, you got a comment or question?
Yeah, so like when you multiply the whole equation, just like as a clarification, does the equation like still remain equal and the same?
Yep. When you multiply the whole equation by a number, it doesn't change the value of the equation, it just changes the look of the equation. Thank you for clarifying that. Once we have opposites, that's our goal, is to get opposites. What we're going to do is we're going to add the equations together, and we will end up eliminating one of the variables. Then we will solve, and then the final step is the same thing you learned with substitution. Once you have one of the numbers, you plug it back into one of the equations, you get the other number. Now again, it's probably not going to make sense until you see it done. So we're going to jump right in and start doing it. So we're going to solve this system using elimination. Now, I like to emphasize to my students and encourage them to not lose sight of the goal. When you're solving a system, you are trying to find an ordered pair that makes the system true. So I like to write out my little empty ordered pair, empty parentheses, to kind of get set up so I don't lose sight of that goal. Now, this first time, you're going to have no idea what to do. It's not instinctive. There's no way that I could say, hey, what do you think we should do? And then you would know. So I'm going to demonstrate, and then you'll start to understand. So what you're doing is you're looking in columns. And so you're looking here. Those are the x's. They're on top of each other, but we would like them to be opposites. Well, right now they're not. Or, if we look at the y's, they're stacked on top of each other. We'd like them to be opposites, but they're not. We need to choose one of them. You don't do both, you do one of them. So I am going to choose the x's because the numbers are a little bit smaller, might be a little bit easier. So we're going to focus just on this. And I want to turn these into opposites. So what I'm going to do is I'm going to multiply the whole first equation, and again, this is a skill you learned in chapter 5. I'm going to multiply the whole first equation times 2. What will the x term turn into when I multiply the whole thing times 2? Tristan? 6x. Very good. So I'm going to rewrite it over here the whole thing, 6x minus 10y equals 30. And just like Sharik said, that's an equivalent equation. It will draw the same line on a graph. It has the same solutions. All I did was change the look of it. But now what I would like is I would like the second equation to come underneath it right here, and I would like this term to be a negative 6. So I want this to say negative 6x. What do I need to do to the second equation so this becomes a negative 6x? Eric? Multiply by negative 1. So if I multiply this by negative 1, that will become a negative 2, not a negative 6. Negative 3, let's see. Negative 3 times 2, yeah, that'll be a negative 6. So I'm going to multiply the entire second equation times negative 3. And now I will get my negative 6, but now I have to multiply times everything, minus 12y equals positive 3. Now I have achieved the goal of opposites. They're right here. This is what I was trying to do. Right. Does anyone have any questions on how I accomplished that goal? Yes, and then yes. Yep. If I wanted to, we could have multiplied this times 4 and this times 5, and we would have gotten opposites as well. Okay? Very good. Anit? No, you just have to accomplish the goal of getting opposites. We chose these numbers from our brains, so it does not matter what you multiply by. Yep? You should. So now here's where the elimination happens. Just like in elementary school when you learn to add things by stacking them up, we're going to do that again right here. We now have stacked them up, and we're going to add down. And we go column by column. In other words, we work with this going down, and then this going down, and then that going down. Okay? So, the 6x and the negative 6x will cancel each other out, and it will disappear. Now we have a negative 10y and a negative 12y. That's a negative 22y. And then I have a 30 and a 3. That's 33. Now solve the equation. How many steps is this, Alicia? 1. One simple step. Divide by negative 22. Divide by negative 22. And we get y equals what? Y equals what? This guy? Yeah, it could be negative 3/2, it could be negative 1.5, or negative 1.5. It doesn't really matter. So, we've got half our answer. We now know the y coordinate is negative 3/2. How can we get the x coordinate? Catalina? Yeah, well, in fact, you're right. We can plug it into the one we haven't used, but we've used both of them. Any of them. We can plug this value into any of the equations. In fact, it could be this one, this one, this one, or this one. To me, one of them looks easier than the rest. To me, this one looks the easiest. None of them look terribly easy, but that looks the easiest. So we'll use that one. So we get 2x plus 4 times negative 3/2 equals negative 1. Doing some quick mental math, you will see that this is really 2x minus 6 equals negative 1. It's a two-step equation. You should be an expert at it. Add 6 to both sides. We get 2x equals 5. x equals 5/2 or 2.5, either way. And so we have found the solution to the system. So I know my work kind of goes in a bit of a circle. We started here, we rewrote it, we added down, solved it, and then we plugged it back in and solved it here. Okay? Does anyone have any questions on any of the steps? Tristan? What do you think? It's going to be a sometimes. Today is a case where I chose a moderate to high level question. Well, it's not really a moderate level question, but a moderate level example. And we're going to actually work towards the easy ones. So most of them will actually not be this messy. But now I want to relate to something I showed you already. I would like you to look here. What do you notice? We got a bunch of people whose light bulbs went off. Brian?
The two lines that you use are the same ones that we just saw.
Yeah, and any other observation? You're absolutely right. It's the same system. What else do you observe? Brandon?
It's the same point.
What's the same point?
The coordinate of the coordinate that we solved for is the same as the solution of the system of that.
Right. Does that make sense? Yeah. This point right here is, look, 2.5, comma, -1.5. So that point right there could be found using graphs, but we just eliminated that part by using this method called elimination. Any other comments, questions, observations?
Like, from your opinion, which way do you think is easier to?
That's something we're going to talk about at the end of today's lesson. So we're going to come back. Please ask your question at the very end. Okay, so let's continue trying to understand the method called elimination. Now, again, this method is not very instinctive. It's not like you could just go, oh, I get it, and know exactly what to do in all the different cases. So I still have to guide you a little bit, but maybe some of you are catching on. Let's see what you observe about this system versus the previous one. Anyone have any observations that you could make? Zabari? Okay, easier to use the Y's. What led you to that conclusion?
Because you can just multiply the first equation to the same y.
Okay, so you think there's something about the first... Go ahead. Good. So he actually said a whole bunch of observations. He doesn't even realize it. Yes, we're going to eliminate the y's, and not only that, we can do it just by multiplying the first equation. We don't have to multiply the second equation by anything. And if you look back at the notes, I wrote multiply none, one, or both. So the first example was both. The second example is 1. And so, if we just multiply the first equation, we will end, we will get negative 14x minus 2y equals negative 4. The second equation is going to stay the same. 5x plus 2y equals positive 4. So our life was a bit easier. Not as much thought involved. Still have to pay attention to details. Now, like in elementary school, we add down. these will cancel out, and so we've got negative 9x equals 0. What does x equal? Kayla? I'm sorry? Well, you were. Maybe you didn't realize you were, but you were. Sebastian? 0. X is 0. And so, the first coordinate for our solution is 0. Now, as Catalina pointed out in the last example, we can plug that into any of the equations, but one of them is much easier than the rest. Which one's the easiest one to plug it in? Anissa? Yeah. If you plug this here, you get 7 times 0 plus y equals 2. This basically disappears and you get y equals 2. So our ordered pair is 0, 2. And so here is the solution to this system. And we use the method of elimination to accomplish the goal. Does anyone have any questions on the method or the process that we went through? Anit? Yes, you will see an example of that. Very good. So now let me relate it back to what you've seen in the past again. So now I have this set up. Let me see if I can do this. Get rid of this and this. Put this and this back. So, hopefully you can see, I don't know, it's a little bit too small for some of you, but this is the system that we just did. And what do you notice about the graph? Cherie? Never mind. I would have thought everybody's hand would be up with confidence. Kezekai?
The point that we did is over there.
Right. What point? What's this point called?
Solution.
It's the solution, and it also has another name. What's the other name, Kamoy? Yeah, it's the point of intersection. So the point of intersection is 0, 2, which is also called the solution. So that can be found with the graph, but we eliminated that part by using clever math and using a clever method called elimination. Are there any comments or questions? Good, you guys are doing well so far. Let's see how you do on your own. Checkpoint number 1. Solve this system on your own. You got 3.5 minutes. If that turns out to be not enough time, I will increase the time by a minute, but I think that should be fine. let's see how we're doing with elimination so far. 5, 6, 7, 8 confident people, 9 confident people. Okay, when I call on you, make sure you use your 2014 super joyous loud voice. Maria, Shelby, and then Tristan. Maria, what did you get?
-2,0.
Thank you for using the happy, joyous 2014 voice. Shelby. Okay, I actually heard you very well. Tristan?
-2,0.
Okay, thank you for that enthusiastic response. Yes, it is -2,0. Good job. Give me a thumbs up if you got it correct. Okay, put your thumbs down. That's most of you, although there's a couple of people who didn't put the thumb up that I know got it right, so I'm not sure what's going on there. But are there any comments or questions about this one? Ania? Yes, I will. I'm going to come to your desk individually. But there was something about this question that was different than the other two. Anyone know what was different? Keziah and then Brian? Okay, what were you going to say?
You could have multiplied done either x or y, because if you would have multiplied one by one and the other by positive number, positive number, you would have still gotten.
Yeah, your explanations, both of you, were a little bit kind of haphazard, but you got the basic idea that if you notice, these x's are compatible numbers, so you could have multiplied the bottom equation by 3 and you would have gotten opposites. But if you looked really carefully, you would have noticed that the y's were very friendly numbers as well, and if you multiplied the top by +2, you would have gotten opposites there. So you had your choice of which ones to multiply by. Yeah? That's a very, very good point. You're the first person to bring it up at all in any of my classes. And yes, you can divide. So if you wanted to divide this one by 2, you could, but that would make this very messy. You understand why? Because it's not divisible by 2. It would become a fraction, and then it would just make your life a little bit more difficult. But there will be cases where dividing would be a very good choice. Very good point, Elise. All right, so let's continue to expand our understanding of the elimination method. The elimination method only works if the terms are lined up properly. The x's have to be stacked up, the y's have to be stacked up. Otherwise it doesn't work. So you're going to get some problems that you're going to be asked to solve where they are not lined up like in this system here. Now this bottom equation is in standard form, so all we need to do is fix this top one and then proceed with all of the other steps. So how can we get this top equation into standard form so that we can stack them up? Got 5 ideas? 6 ideas? Sebastian? Yeah, simply if we add 4x to both sides, this will jump from here to over here, and the sign will flip, but then it'll be lined up. So this will turn into 4x plus 3y equals -6. So now the x's are on top of the x's, the y's are on top of the y's. Now we can proceed with the other steps. Now we need to find opposites. So what can we do to get opposites? What suggestions do you have? Zabari, and then we'll come over here.
Multiplying the bottom by negative 1.
Okay, Catalina, what were you going to suggest? Multiply the bottom one by negative 5? By negative 1, I'm sorry. I don't know where I got my negative 5 from. Times negative 1. Anyone have a different suggestion? Brian?
You can multiply either equation by negative.
Yeah, you can multiply either of them by negative 1. But the important thing is to recognize that to flip this sign, you just multiply by negative 1. Very good. So the top equation is going to stay the same. I'm just going to rewrite it over here. 7x plus 3y equals negative 15. And then the bottom one, all the signs are going to flip. Negative 4x minus 3y equals positive 6. And now we're going to add down just like in elementary school. Does anyone have any questions on how we did this step right here to get from here to here? Do you have any concerns or questions about it?
Oh no.
Okay. So now we just add down 7x minus 4x, we get 3x. This will disappear, equals negative 9. X equals what? Caleb? No, your hand was up that time. Okay. Alicia? It's negative 3. And Kayla knew the answer too. So we already know the x-coordinate of our solution. It's negative 3 comma something. So we just need to plug it back in and simplify. I don't know if either of them are easier. Anyone have a suggestion on which one we could plug back into to make our lives easiest? Ania? I'm sorry? Top equation? Yeah, I don't think it's going to make much of a difference either way. They're both, kind of a bit of a pain. But yeah, we can use the top one. 7 times negative 3 plus 3y equals negative 15. And so that's a negative 21. So if we add 21 to both sides, we get 3y equals 6. Y equals, Kayla? 2. Okay, y equals 2. And so we have found the point of intersection, the solution to the system. Does anyone have any questions on how we did that? So the new part for this example was that the equations were not lined up. Everything else was something we did in the previous few examples. That was the only thing new. Does anyone have any questions about that? All right, checkpoint number 2. Let's see how you do with this. You got 3.5 minutes. people still working, take another 30 seconds to finish up. But when the bell rings this time, that will be all your time. Now, I could let you keep going, because there's quite a few of you who are still kind of plugging your way through it. But I already know, those of you who are still plugging away, is your mistake was actually way back at the beginning. And so the struggle's not going to end for you. You'll find out why in a moment. My confident students, the ones who, well, you'll see in a second, I saw them sit up after like a minute and a half. That told me that they caught something that the rest of you didn't. So my confident students, what is the solution to this system? Kamoy, Kezekiah, Brian, Sharif. What'd you get, Kamoy? 4,6?
4,6.
So all the confident people got 4,6 because it's 4,6. Does someone want to point out the detail that many students missed to those others? Kamoy, can you explain the detail that a lot of people missed?
The second equation is
Yeah. The second equation wasn't in standard form. The y was on the left and the x was on the right. You had to flip those around also. So that's why I didn't want to torture you and have you keep going more and more and more to keep plugging away when you actually made a mistake way back at the beginning. So you had two choices. You could have rewritten the first one in standard form and then switched this one around. And here's what that looks like. 4x minus 5y equals negative 14. Negative 8x plus 3y equals negative 14. I had a student in another class who did something creative. Rather than do that with the second equation, what he did was when he rewrote the first one, he put this right in front. So it wasn't technically in standard form, but they still stacked up. So what he had was negative 5y plus 4x equals negative 14, and then 3y minus 8x equals negative 14. And even though that's not standard form, it still works. Okay? So either way is good. Okay? Alicia, Brandon, Catalina.
The same thing, right? The y in front and the x, but I see it.
Okay, so I can come look and see. Then you made a mistake somewhere in the not easier part of the process, but the more kind of following steps part of the process. Brandon and then Ania.
I think what we did was that negative 1/2
Okay, well, so you did this right here. So what did you do to get opposites?
I multiplied the second half of the first equation by 2.
So you multiplied this one by 2. Good. So you multiply this times 2. And so you end up with negative 10y plus 8x equals negative 28. And then you add down. You get negative 7y equals, and that's negative 42. Y equals 6.
But I have the x.
But that's a matter of plugging it back in and just, all you had to do was plug the 6 back in right here. 5 times 6 is 30. 30 minus 14 is 16. Divide both sides by 4, and you get 4. So you made a mistake when you plugged it back in. Ania? Got it?
Yeah, I put negative 6.
Okay.
Oh, yeah.
Okay. So, we should be feeling more and more comfortable. Yes, I did trick you a little bit on this one, but you should still be getting pretty comfortable with the elimination method. Now I'm going to do one more example, but I'd like you to put your pencils down. Do not write. I just want you to look. So what's different about this one compared to all the other ones we've done so far today? Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people catch it now. Alyssa? What's step 2?
The 2y, it has
Opposites. It's already done for you. Everything's done. It's lined up, and we have opposites already. Boom, boom, 12x equals 0, x equals 0. Plug it back in. You could probably do the entire thing mentally, for this group at least. So, you had asked Ania half an hour ago if we were going to see one where you didn't have to multiply either of them. So here you go. Should seem pretty easy to you at this point. Any comments or questions about this? Good. Draw a line across your paper. Your classwork is page 77. You're going to do numbers 20, 19, 18, 13, 11, and 8. That's 6 questions. The first 2 questions are going to take you the longest. That's fine. That's the way it's supposed to be. Thank you, my students who Alright, let's see how we did. Colored pens. And here's number 20, part A. And you can mark A and B separately. Same thing with the next question. The system was 3x plus 2y equals 557, and 5x plus 4y equals 974. And then when you solve it, you get a hotel being $140 a night and tickets being $68.50 per pair. Number 19, similar situation. You end up with 2x plus 4y equals 28, and 4x plus 5y equals 45.5, or 45.50. And when you solve that, you get an adult ticket for $7 and a youth ticket for $3.50, and then it would cost $31.50 for those people to go. Unfortunately, these situations are such that if you got A wrong, then you probably got B and C wrong. You could get A right, and you could get B wrong, and then you could get C wrong. You could get A right, get B right. I would hope that you would get C right from there, but you never know. And then there was some just basic solving systems. 18, it was 8, 8. 13 was 10, 8. 11 was 9, 5, and 8 was 3, 6. Comments and questions? Brandon, Ania, and then over here. What? Awesome. Any other comments, questions? Okay, draw a line across your paper. Your homework, it looks like a lot, but it's a standard assignment. It's just separated onto 3 different pages. The book publisher kind of babied the concept and they separated it into 7.3 and 7.4. That was not necessary for us, this bright class. So on 459, that's 7.3. You're only going to do a few of the real world scenarios. Then 466, you're going to do some practice and a real world scenario. And then we are going to continue reviewing the FL 14, day 1, 2, 3, 4, and 5. At the bottom of the page, the FL pages, it tells you what section the concepts are coming from. So if you're stuck on a concept, you have to review. That's the purpose of this. Read the next section. I had originally said you're going to have a quiz next week, but the testing schedule is such that I'm not sure if we're going to be able to do that. So I'm just going to play it by ear. We'll see. I will never surprise you with anything. I will let you know in advance.